This is the third video in the sequence about financial math. The other two are linked in the description. And today we are going to talk about a type of problem that only appears in the Math AI courses. If you are an AA student, you've probably seen in this calculator screen that there is an extra line called PMT that you always leave as zero, and maybe you've wondered what that is about. So that's exactly what we're going to talk about today. Everything else that we've already talked about remains the same, like the different compounding periods or the convention to use a positive sign when the money is coming from the bank to you and a negative sign when the money is going from you to the bank. The only difference is that now, in addition to all of that, there's also going to be this PMT, which is an amount of money that is changing hands in each period. It's either you paying something to the bank every month, for example, or you're taking away some money from the bank every month. There's basically three types of situations in which this happens. The first one is loans. When you borrow money from the bank, they usually don't let you just keep the money for a few years, trusting that you will repay them with interest in the end of that few years. You usually have to be paying a little bit each month. The second type of situation is just when you are saving your money for the future, because in all of the problems that we saw previously, you have an amount of money right now and then you put it in the bank and forget about it for a bunch of years. But that's not usually how it works when you're investing and saving for the future. Usually you have a little bit of money to put in there each month. You don't have a big initial amount to just do something with. Instead, you have a little bit each month that accumulates through time, hopefully also getting interest in the process. And the third type of situation is retirement, when you've done all of your investing throughout your life and now you're not going to be working anymore, not going to be having that extra money to put in there each month. You're going to do the opposite. You're going to take away some money from your investments each month. So now we're going to see examples of each one of these three types of situations. But first, I want to point out a couple of things about the parameters in the calculator screen. Because the other thing that the AA students often wonder about, other than what is this PMT always equal to zero doing here, they often ask why we have two places to say what the compounding periods is. In the example that I have in my screen right now from another problem that I was solving another day, they are both 4, indicating quarterly compounding periods. But you have to say 4 twice in the calculator. You have to say that PY is 4 and that CY is 4. So why is that? Why do we have two separate lines for that? And the reason is that now we have two different things that are happening periodically and over again through time. One is the interest being added to your account like it was before, but the other one is the money changing hands. And in most problems, both of these things are going to be happening in the same kind of periods. So either they will both be monthly or both quarterly. But there are some problems that we run into where those two things are different periods. So maybe the interest in the account is compounded monthly, but you only put money in there once a year, for example. So that's the thing that you need to know. The PY refers to the periods of the payments of the PMT, and the CY refers to the compounding periods of the interest rate. So let's just check that with a very simple example. I am doing 1 as a compounding periods, so it's once a year. I'm putting 1 year for the total amount of my exercise here. 10% interest rate and $1,000 that I put into the bank initially, no PMT, and we expect that to give us a future value of 1100, right? There you go, 1100. But since there was no PMT in this situation, then the value that I put in PY shouldn't matter. Notice that when you change the PY, the calculator changes the CY. She wants them to be the same number, but you can change it back, okay? So I am going to keep my interest compounding once a year with just 1 year. And I'm putting a PY equals 4 for no reason because I'm doing no payments during this year. And let's just see if something happens with the future value. That is the crazy thing, right? It shouldn't change, but it does. Because remember that the big N in the first line of the TVM solver screen, that's not the number of years. that is the number of compounding periods. So now that I have a 4 and a 1, which one of them should I use to decide how many compounding periods? I tell the calculator that there are, and it should be the PY. So in this situation, even though there is 0 PMT, I want my investment to last a year. So a year is 4 quarters. So I need to put n equals 4 there. And now let's see what happens to the future value. And we are getting back the 1100 that we wanted. Now we have already observed before that the same interest rate will give you more money if it is compounded more frequently. So I just want to check that again by putting a 2 instead of a 1 in the compounding periods. I'm not going to change the PY, so I'm not going to change the N as well. But let's see if that gives me a little bit more money. And it does, because now instead of just being 10% once, it was 5% after the half of the year, and then 5% over that at the end of the year. So those are the weird details to keep in mind. PY and CY can be different. PY refers to the number of times per year that there is a PMT happening. CY refers to the number of times a year where the interest is being compounded. And N should be the number of payments in the period, not just the number of compounding periods. It's the number of periods in which there is a PMT. So in other words, N should be the number of years times PY, not times CY. So the other weird little detail that people often ask about is this last line on the screen that says end and begin. What does that mean? Well, notice that it is also called PMT, so it has to refer to the PMT, and it does. So like if you're repaying a loan, for example, there are two things happening. There is the interest that is being added to your loan every compounding period, and there's also you paying the loan. But does the bank calculate this payment as if it's being done at the end of a compounding period or in the beginning of the next compounding period? The reason why that makes a difference is what happens first. Do you first give the money and then the interest happens, or the other way around? This is easier to check with an investment than with a loan. So the example that I'm going to do right now is just one period, PY and CY are 1. I start with PV equals 0, no money, but I'm putting $100 as a PMT. So $100 every year in this case, because PY is 1. Okay, and I'm going to check what happens to the future value. So if I am beginning with 0 money, 10% interest rate, but I'm only going to run this for one period, and I am going to put $100 in there. If this is happening at the end of the period, then I expect my future value to just be 100, because I put that 100 there in the end of the period. There was no time for the interest to happen. And that is exactly what's happening. But if I do the same thing, but putting my money in there in the beginning of the compounding period, then there is going to be an interest in this $100, making it into 110. So that's the difference between end and begin, in case you were curious to know what that means. But the thing is that in the syllabus of the course, they explicitly say that it will always be end. Here, in examinations, the payments will be made at the end of the period. So you don't really have to worry about that. Just make sure that your calculator is set to the end. And in case you were curious, that is something that is nice to know. Now, there is another thing pointed out here in the syllabus. Knowledge of the annuity formula will enhance understanding, but will not be examined. What does that mean? You don't need to know how the calculator is calculating these things. I am going to show you that in the next video in this playlist, but you really shouldn't worry, because they will not ask you anything about that in exams. So yeah, those were all the comments. Now let's solve a couple of exercises. The way that you need to solve this and put it on paper is that you should write down what you put into each line of the TVM solver screen. So I'm going to write them down here on the side as I read through the question, and then we're going to go to the calculator. When Humberto retires, he invests $300,000 in an annuity fund. So that is his initial investment. I'm going to put negative $300,000 here in the PV. It's negative because he is putting it into the bank. Annuity is just the name they usually use for this kind of situation in which you put a bunch of money in there and then take it away a little bit at a time. And then this one earns interest at a nominal rate of 3.8% per year, compounded monthly. So that's the CY, that is 12. He then withdraws 2,800 at the end of every month. So it's 2,800 here as the PMT. Notice that it is at the end of every month. They are, most of the time, they are careful to say that it's and, even though it has been predetermined that it is. It's written in the syllabus. And that number is positive because he is withdrawing money from the bank. So it's going from the bank to himself. Oh, and the PY is also 12, right? Because he takes this money at the end of every month. So part A is asking about 8 years. So the N over there is going to be 8 times 12. He just wants me to find the future value. So let me put the 8 times 12 here. And the future value is this much. Let me write down. Now, as usual for money problems, we are writing down our answers to 2 decimal places, okay? That's the cents on the currency. That's the way people usually talk about currency. And part B is calculate how many times he is able to make these withdrawals, because you see, his money is getting eaten up quite fast. He started with 300,000 and now he only has less than 100,000, and it's only been 8 years. So the question now is, how long is the money going to last? And in order to do that, the question is going to be the N, how many times he can do that, and I'm going to find it in the calculator by putting the future value equal to 0. When is the money going to run out? And the answer is 131 times. There is a tiny little bit more than 131, like 131.08, but that's not going to be a full 2,800 that he still has there, so I don't think it counts as part of the answer. The answer is that he can make these withdrawals 131 times. So almost 11 years. If the question was how many years, you would say 10 years and 11 months, I guess. But that was not the question. Question was how many times he can make the withdrawal. So the answer really is just 131. Notice that in the beginning of the video, I told you about 3 types of situations. The first problem was about the retirement fund. The second one is going to be now about the investment. She's not retired yet. She is just beginning to put money into an account to save for later in life. So in 1st January 2022, she puts $1,000 into a bank account. That's going to be the initial value, right? The PV, which is negative because she's putting it there. The interest rate is 4 compounded monthly, so the 12 goes here. At the end of January and the end of every month after that, also that's going to be the PMT. They're telling me about the end of the month again. You see, the initial value was on the 1st of January, so at the beginning of the month, but the PMT is going to be at the end of the month. She deposits $100, so that's also negative because it's also her putting money into her own account. That is also happening monthly, so there's another 12 here. And calculate the amount of money in her account, FV, at the start of 2024. Okay, so that is 2 years later, so it is 24 months to put at the end. Here is all of the information already in the calculator screen. Let's ask it for the future value, 3577.43. This question even asks us explicitly to put our answer in 2 decimal places, but even when they don't, I do that anyway. And part B, find how many complete months it will take for her to have more than 5,000. So again, the same kind of question structure as the first one. In part A, they give you a fixed amount of time and ask for the future value. And in part B, they give you a future value that they want and ask you to find the time. That is very common. So now the future value is 5,000 that they want. I'm going to put that as a positive 5,000 in the future value, as if she was withdrawing all of that money. She's not necessarily going to do that, but she could. And that is the way that you put this question into the calculator. So you put the 5,000 here, ask for the number of periods, So that is 36.5 in three significant figures. 36.5 what? Months, right? This whole thing is happening monthly. But the question was how many complete months it will take for her to have more than 5,000. And the thing is, nothing is happening at half a month. So the answer is not really 36.5 months. It is 37 months. Because what this 36.5 coming from the calculator tells me is that 36 months is not enough to have 5,000, but with 37, you will go over 5,000. That is also what they mean by complete months. And in case you were not 100% sure, you can always use the calculator itself to check, like, what happens with 36 months? How much money does she have? Not quite 5,000. But what happens with 37 months? Well, that's the first time that she has a little bit more than 5,000, which was what the question was asking about. So the third type of situation that I told you about was a loan. So that's what is going to happen in question number 3. Brian wants to buy a car that costs 14,000, but he cannot afford the full amount. Now he has two options to finance a loan. So for part A, we have a 6-year loan, 14%. Notice how the percentages are higher for loans because that is how banks make money. No deposit required. That means that he's going to finance the full amount of the car. He's not going to take any money out of his own pocket towards those 14,000. So that is the PV is 14,000 is how much money he is taking out as a loan. This is a positive number because it is coming from the bank to him. The bank is giving him the money at that moment. It is compounded quarterly. So I put a 4 over here. And repayments are also made each quarter. So we are again in the nicer situation where PY and CY are the same. This is 6 years, so 24 at the end. He wants to find the payment made each quarter, so that's the PMT. But what is the FV? So listen, in loans, the FV is always going to be 0 because at the end of the loan, you need to finish repaying your loan. So you can't finish this situation still owing any money. Put all the information in the calculator and then ask for the PMT. The answer is 871.82. I don't like to put the negative sign in the answer because that's not the way the question was phrased. I think they would not take away a mark from you if you did put the negative sign over there, but anyway. So that's the first part of part A, the repayment made each quarter. Now they want to know the total amount paid for the car. That is a simpler question. It is the quarterly payment times the number of quarters, the number of times that he made this payment, so times 24. That's quite a bit more than 14,000 because again, that is how it works. That is how banks make money. And then the third question here is a very simple thing. It's just a matter of vocabulary. I know some people who tend to answer this kind of question was like, oh, it was 14%. No, 14% was the interest rate. He is asking you to find the interest, not the rate. The interest rate is this percentage that is being applied to the amount of money, but interest is how much did you pay that was not actually the price of the car. So it's those 20,000 and something minus 14,000. That is a super common type of question, okay? So remember this distinction between interest and interest rate. Okay, so I'm not necessarily going to finish finance option B because it's more of the same, but there is something that I want to point out here. A 6-year loan at a nominal annual interest rate of R, which is what he's going to ask you about. This one is compounded monthly. And then the terms of the loan require a 10% deposit. Remember that in the first one, there was no deposit, so you actually borrowed the full 14,000. This time you don't, because 10% of that you need to pay from your own pocket. You're actually getting a loan for only 12,600. So that's the amount that you have to put in your PV, okay? But now I really should show you an example of when the PY and the CY are not the same. Let's read this question. Yejin plans to retire at age 60. She wants to create an annuity fund, which will pay her a monthly allowance of $4,000. So that is the PY. The PY is 12. She wants to save enough money so that the payments last for 30 years. Financial advisor has told her that she can expect to earn 5% interest compounded annually. That's the CY. The CY is 1. So that's the tricky bit, right? Because the N is supposed to be 30 years. She wants this to last 30 years. But we know that what we put into N in the calculator is not the number of years, it's the number of years times the periods. Was it the PY or the CY that we need to multiply this by? Do you remember? I told you in the beginning of the video. It's the PY. So it's actually 30 times 12 up there. The PV is the question, right? Calculate the amount that she needs to have in her annuity fund. And FV is what? Again, FV is 0 because the question is that this money needs to last 30 years. After 30 years, there is no more money, so 0 money as the future value. So there you go. That's the answer. A very large number, but again, it's supposed to last her for 30 years, so it better be a big amount of money. And the second question is about how is she going to get to having this money that she today does not have. So she is going to save a little bit each month. The investment account hasn't changed. So 5, 12, and 1 are still the parameters of the investment account. 5% interest, the payments being done monthly, and the compounding being done yearly. But now she's 28. She's going to save until she's 60, so that is 32 years. So 32 times 12 as the N. How much money does she have now? I don't think any money. Yeah, she currently has no retirement savings. We want to figure out how much she needs to put there each month. And the future value is that we calculated that she needs to start her retirement. Okay, so it's the answer to part A right here. So now let's calculate the monthly payments. $816. That's not that bad, is it? To pay $800 each month, and in the future you're going to have $4,000 each month.